Right, folks, we'll carry on from last lesson. We met logs and exponentials mainly last lesson. If you remember, we looked at the exponential graphs, which could be in the form y equals a to the x, where a is a number that we're given. So, such as y equals, we met anything like 3 to the x, y equals 5 to the x, etc. And they all produce graphs that look a bit like this one. They get big rather fast, and anything to the power 0 is always 1. The only way that they'll go down rather than growth will be if the number a is between 0 and 1. So if a is between 0 and 1, it'll end up as a decay graph, such as that. Y equals a half to the x, because you can think a half to the power 2 is a quarter, half to the power 3 is an eighth. It's getting smaller and smaller. You've also got a power button on your calculator, and if you press shift, the power button, then you'll see it's got the log, its inverse on it. We said logs were the inverse, if you recall, because they're sort of the opposite of exponential graphs. There's my common exponential graph going through 1. The common log one is a reflection of that graph in the line y equals x. Try that again, y equals x. Doesn't want to write. Anyway, so the reflection graph here, if it worked. Oh, it's done a lot of scribbling now, a bit later. Right. So they're interchangeable for logs from exponentials if you change the x with the y. So the log graph, this one, log y equals log x, would be the same graph if we do the exponential with the y and the x changed around. So we've got a to the y equals x. Those are interchangeable. That will both be plotting this one here under there. Both those graphs will plot that. So they're interchangeable. So you can see that 2 squared equals 4. And that means that log to the base 2, log to the base 2 of 4 will equal 2. And here, just to do one of them for you, log to the base 3 of the answer we'd have here equals 2. Oh, right, well, I don't know what to put here, but I do know that 3 squared is 9. And therefore that must be log to the base 3 of 9, and it's going to equal 2. If I was unsure, I could press this button here, put in those details and confirm it. So I'll just give you a couple of minutes only to finish those others off. Okay, so let's hope you can check with these ones. I'm trying to draw them in different colour. Here we are. So I'm having to go at them myself now. I know that. Oops. 4 to the power 1 would be 4. 4 to the power 2 would be 16. 4 to the power 3 would be 16 times 4, and that will give me 64. So log to the base 4 of 64 must be 3. I know that 5 squared is 25. That's impressed you. So that means that log to the base 5 of 25 will be 2. Do I know that 7 to the power something is 204, sorry, 2401? No, I don't. Oh dear. I think I'll have to play with that on my calculator, or I can put this log in to the machine. Here, I'll just enter this into the calculator. So I'm shift that power button, put a base of 7 on it. I'll do it again. And type in the 2401, and the calculator's telling me it's 4. So from the machine I can get that as 4, and therefore that power will be 4. You can check it. And now 6 to the power 5 is something, and that means, what is 6 to the power 5? I might need to put that in my machine. Oops. That was 7776. So you put the log to base 6 of 7776 is 5, and again you could check it if you wished. Okay, here's some true and false questions for you to have a go at. Basically what your idea is that you change them into power questions and answer them without using your machine if you can. So if I just do this first one, is 2 to the power 4, is it equal to 8? That's using that rule that log, so y equals log base a of x is equivalent to or interchangeable with a to the y equals x. So I've sort of used that to get 2 to the power 4 equals 8. Is that true or is it false? Actually 2 to the power 4 is 16, not 8, so that one was false. So you have a go at the others. I'll give you a few minutes to have a go. Talk to your partner. Do them together. start putting them up for you to check. Interesting one, this one. You could work them both out actually, because you don't really know this yet. However, you have had a homework on it before that actually I'm not right now. This one is in fact log to the base 2 of an eighth, if you recognise that decimal. And this thing, if you've learnt anything from the homework on logs, they told you that if you have a number before a log, you can put it up as a power. So well done if you remembered that from a homework. That's like 8 to the power minus 1. And 8 to the power minus 1 is an eighth. So that one was also true. This one, does it equal 0? No. This one though, 7 to the power 0 is 1. That is true. This one, 10 to the power a half, is not equal to 0.1. This one, again a little bit tricky. A to the power 3 over 2, is it equal to this thing here? Well, that's telling you it's the third root, so we could really write that as a fraction power. It's squaring it and then third rooting it, so it look like that. So actually, no, it's false. It's 2/3 and they're not the same. This one, a to the power 1 is a. That's correct. This one, 3 to the power, my head's in the way at the moment, I'll move that. 3 to the power 4, it says 3 to the power 4 equals x take 2, and if that x was 83, that would make that 81, because 81 is 83 minus 2, so that's true. And then last one we've got here, we've got 2 to the power and x equals 2 to the x, yes, so that one was correct. I would say let me know your mark out of 15. Maybe you could let the teacher at the front know your mark out of 15. Let's hope it's higher than 10. And if not, maybe I need to look at this again sometime. Right. Let's move on. Okay, lesson 2 on logs. We've practiced a bit of switching between exponential and logs again, but we're going to see how these can affect each other in an equation, remembering one's sort of the inverse of the other. We've also got to know about the rules of logs, but you have done this on the homework, so it should be just a refresher. Okay, the inverse of y equals e to the x is log to the base e. And here that's how we'd write log to the base e. And that also can be written as ln x. So those are the same thing. And they're known as the natural logs. Or the natural log, I should say. Natural log. If you remember, e is just a number. E in your calculator, you can find it by pressing the E button, which is under tool, and putting a 1 afterwards for its power, and that should come up for you. So the E button's under tools. Should come up as 2.71828, etc. It goes on forever. It's like pi. They're both irrational numbers. So ln is the inverse of e to the x. If we look at the picture of those, here's e to the x, a graph which gets bigger and bigger and bigger quite fast, because basically it's just the graph of y equals 2.718 to the power x. So you can see it's increased really quickly. If that was a power 10, that'd be huge. And to get the log graph, because it's the inverse, you're just reflecting it in the line y equals x, changing the x and the y. And you get that graph there. Y equals x. If you also recall from last lesson, we said that graph y equals e to the x is special. Can you remember why? Well done if you can. It's just that the gradient of this graph is in fact the graph itself. So the gradient at that point is sort of, oops, there. It's not going to let me join on it, but oops, here we go, is the same as wherever you are on the curve. And that means that when you differentiate e to the x, it stays e to the x. Amazing. Right, solving some equations using the logs. Right, this one just asks us to find it. So 3 significant figures. So all you can do is pop it in your machine, press 6, then the E button under the tools, and then put -3, and you should get an answer. Comes out at, if you've times it by 6, it comes out at 0.2987, so 299. To get answer to part B, you just type it in your machine. You've got a fraction button there, One fraction button is under the orange button. And the ln button, you have to press Shift and then E. And let's hope to 3 significant figures you're getting this. Right, now, without a calculator, find the value of these. So I said E and ln are opposites of each other, like times and divide. So they cancel each other out. And for part A, the answer's just 6. For part B, you can't cancel them out straight away because they're not next to each other. So we've got to rewrite that as E ln e to the -3. Just brought it from the bottom to the top. Now they can cancel each other out and the answer will be -3. Question 3, find x. Here we've got ln and an e next to each other. So they'll cancel each other out and give x just equals 21. Easy one, that one. Part B, bit more to it. Might need a bit of your homework knowledge. The e and the ln can't cancel out because there's a -2 in the way. What you learnt from your homework is that if you've got a number before a log, you can put it up as a power. Now the e and the ln cancel each other out. So we're left with, let's draw a line here, we're left with x to the -2 equals 1 over 36. And then we can write x to the -2 as 1 over, it's a bit of delay on here, x squared equals 1 over 36. And then hopefully you can see 1 is 1, x squared is 36, so x equals 6. Now the question is, can it be -6? Discuss it with the person next to you. What do you think? Hopefully you've said 1 or 2 words. Whatever conclusion you've come to, let's see if it matches mine. If we have 6, it's got to go back in the question, which is fine. You can do ln 6, but can we do ln -6? If we look at the graph of ln, e to the x is that graph, ln is this graph. That's any log graph has that sort of pattern. We can put 6 in and get a value, but actually there are no answers for negative numbers. You can't log a negative number because there isn't any answer. So here, -6, you just can't log it, it's no answer. So it can't be -6. The only answer we can have here is 6. Right, 2 more questions, getting a bit harder perhaps. It says solve these and give the answer in terms of E. So what we need to do to get rid of an ln is to E both sides. E and the ln next to each other, so we just got 3x plus 4 equals e to the 12. And then just rearranging to get x on its own, we'll have e to the 12, subtract 4 over 3. Next one. We can't e both sides straight away because there's a half in the way, so get rid of the half. So if I times both sides by 2, Now E both sides. Cancel out. You may think there's more than one way to answer some questions, and you'd be right. Here, we could have remembered our laws of logs and put the half up and written that as lnp to the half equals 4. Then e both sides and got p to the half equals e to the 4. Then squared both sides and got p equals e to the 4 all squared. If you if you power a power, you times them. So that just gives me e to the 8 as I'd had it before. This one over here says question 5, leave your answer in terms of ln. So we just want ln in the answer for x. So if we ln both sides to get that, get rid of the e. Like that's a quarter. E and the ln cancel out. So x just equals a half ln per quarter. And if you wanted to take that a step further, you can bring the half up and call it ln a quarter to the power of a half. Power of a half is saying the square root. The square root of 4 is 2. So that equals ln of a half. Last one, part B. Wouldn't ln both sides straight away because you can't cancel anything out. You need an e without anything before it in order to get rid. So my first job probably would be to get rid of the 9. Add 9 to both sides, then times by the 10. Oops, I've said 90, that's 11, isn't it? What a nitwit. So that's 110. And now just ln both sides to get rid of the e. And then we've just got m minus 1 equals ln 110. So final answer would be m equals ln 110. And then afterwards take away 1. It's not ln 109. You are not ln in the negative 1. It's a separate term on its own. Okay, on the whiteboards, have a go at this one. So it'll end up with your answer in terms of E. Don't find me any decimals, just leave your answer with an E in it. Trying to find X, by the way. Hold up your board so the teacher can check. And does all of your boards match the one on the front? Let's see. Give yourself a tap on the back if it does. If not, maybe your partner can help you. Right, ignore that. Oops. Oops. Okay, ploughing on. This is just what you did in the homework. When studying indices, we found the important results. We knew that a to the power 1 was a. So this can be written in log form. as, using that conversion, log to the base a of a equals 1. And a to the power 0 equals 1 can be written in log form. Log to the power a of 1 equals 0. So those are two results which are worth bearing in mind. If we had log to the base 2 of 2, then that would be 1. Log to the base 7 of 7 would be 1. And then on here, log to the base any number you like, as long as it's positive, 847 of 1 will be 0. Whatever base you pick, if you log in 1, it will be 0. Important to remember these. Right, the laws of logs that you met in the homework. Add a log, as long as the same base equals log of x times y. So with the example here, they're both base 2. So the answer will be log to base 2 of 3 times 4, 12. Division law. Well, that means if you've got a log to the base a and a log to the base a and you've got to subtract them, it's the same as writing them as a divide. So with this question, we've got log to the base 2 of 3. Take away log to the base 2 of... My head's in the way. Can you write your answer on the whiteboard for this one? What do you think? I try and find the sheet that's not got my head on it. I'll just make my head small before I put this up. I think it's a number 4. So I'll write on top of it. So that equals, hopefully it is log to base 2 of 3 divided by 4 3/4. And the last law we've been using already, power law. If you've got a number before the log, then we just take it up to the top. So 3 log to the base 2 of 4 can be written as log to the base 2 of 4 to the power 3. And if you know that could be written as log to the base 2 of what's 4 to the power 3, I hope it's 64. Could be wrong. No, it's not. It is 64. So I know they've been on your homework, so I won't spend too much time doing them. I'll let you get on. However, just looking at 1 or 2 maximum. Right, this is a single log. So we've got here a number before the log. I need to get rid of that first. So that's 3 squared plus log. Get rid of that 2 as well. So I do that as my first step. Then I've got a log, add a log. So we times those together. Try and do that in one step. I know that 3 squared is 9. So times 9 times 2 is 18. Squared 36, and then subtract. You can write it as a divide. And hopefully we realise that cancels a little bit. 2 6s going to top and bottom. Oh, in fact, it was a half, wasn't it? Silly, silly me. Right, that's that one. I want to copy that if you haven't already. This next question's to unravel a log. So we're given log to the base 10 of that thing, and we've got to write it in terms of separate logs. Now, log to the base 10 before I start is known as the common log. And you don't, if there is no base written on a question like there isn't here, it means it's the common one and there's a base 10. It's just automatically thought of as base 10. So there's no need to keep writing 10 if it's to the base 10, leave it off. So unravelling this, we know that timesing sends us back to adding, and dividing sends us back to subtract. So I'll maybe write in 2 steps. I don't know if that's about to appear any second. I've written it. Oh yeah, there you go. Delayed reaction. Right, and then we can split these up because timesing is the same as adding. And lastly, bring any powers down to the front. And that's where we'll leave it. So it's separated out into the log A, B and C. You can put base 10 on them if you want, but there is no requirement to write 10 there every time when it's just a 10. Right, couple for you to have a go at. You've got to write them as just one logarithm. Part B is a little bit tricky because you have to get rid of the -1. You have to write -1 at some sort of log and then get it in there. But just have a go at A first and then B second. Okay, I hope you've sussed A out. 15/2. Basically doing the 3 times the 5 and dividing by the 2. Or think of it as 3/2 times 5, which again is 15/2. But its equivalent obviously is, if you prefer to write it as a mixed number, 7.5. And you can put the base 10 in if you wanted to. Up to you. Question 2, just another minute or two, because I bet many of you are not getting rid of the -1. My hint would be, if you need one, remember log of a base, if the base and the number are the same, the answer is 1, so log to the base. Wrong base 10, aren't we? Log to base 10 of 10 is 1. That's my little hint. time up, hopefully. And there we have it. So nothing happened on the first row. Second, put the 3 up as a power, the half up as a power, and I've written 1 as log to the base 10 of 10, but minus in front because it's minus 1. Now we can times the 8 and the 4 and divide by the 10. So that would leave us with 32 over 10, which is the same as 16 over 5. Or you could write 3.2. Remember that putting the 10 there is personal preference. Probably just leave your answer as log of 3.2. You know, base there, they assume it's base 10. Right, here we've got some more questions, putting the logs together. Some of them are easier. Some of them are trickier because they've got different bases on, perhaps. Have a go at these on your mini whiteboards. I'll give you a few minutes and then we'll see what you're doing afterwards, basically the textbook. If you're very quick on these on the board, you can get a textbook from the back of the room and get started on the exercise that's on here. I don't know if it's exercise 7B, and it's on page 117. If I can get it to come up without losing it. No, dear, mess that up now. You can see an answer. It's anyway, exercise 7B if you've finished everything. It's really hard to stay quiet. Hopefully I'll be back with you on Wednesday. La 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 la! Not quite there yet. So remember, it's exercise 7B if we finished. I'll write that on here, even though it's going to come up in a moment, but before these blobs disappear. So exercise 7B, page 117. That's in the year 1 textbook at the back of the room. Go and get yourself one. Start on, it says underneath me, start on a question you feel comfortable, but make sure you push yourself towards the end of the lesson. Looking at this video, it seems to be 47 minutes, so there should be a good amount of time for you to do a few questions. Okay, I'll stop to reveal them. That one might surprise you, just to go over that one in case it does. Log to the base 4. Well, how we do that one, I personally write that as -1/2. Leave that a minute. Put log to the base 4 of 4 squared. Log base 4 of 4 goes to 1. And the 2 can come down to the front. So you bring your 2 down to the front, so you get -1 times log to base 4 of 4. And base 4 of 4 numbers the same, things the same, that's just -1. And a bit similar with this one here. You've got log to the base 3, so I would be writing that's 2/3 log to the base 3. You've guessed it, 3 to the power 3. So you bring your 3 to the front. 3 times 2 is 6. 6 over 3 makes 2. Log 3 of 3 cancels out to be 1. So you're just left with an arrow. That's it. 2, and then the other ones, they're back to easy ones. And that's note no -9, as you can't log a negative. Right, off on the textbook now, and I hope to see you on Wednesday. Bye bye.